Hello everyone. Today we're going to be talking about multiplying rational expressions. This is a Kuta software infinite algebra worksheet. So let's go ahead and get started. The prompt is simplify each expression. So what we see here is we see two rational expressions. A rational expression is essentially a ratio. So when you think ratio, you're thinking division. And an expression is a term without an equal sign. So we have rational expressions we're asked to simplify. Now, with multiplication rules and fractions, we're going to multiply numerator times numerator, denominators times denominator. So this could be rewritten as the following. 53 times 46n squared over 43 times 31. What I like to do in this stage is cancel or reduce anything if possible. So we're going to be looking for common factors with the numbers in the top or the terms in the top. That includes some variables and anything in the bottom. This is an interesting case because we have three prime numbers. With those three prime numbers, there's only the factors of themselves and 1. So 53 is only 53 times 1, 43 is only 43 times 1, and 31 is only 31 times 1. So in this case, there is nothing that they have in common that could reduce. So we're just going to have to simply multiply the top times the top and the bottom times the bottom. When we do that, go ahead, let me get my calculator. 53 times 46, we get 2,438, and don't forget about the n squared. Divided by, we're going to do 43 times 31, and we get 1,333. And that is as reduced as it can be because there's no common factors. So let's go ahead and move on to a different problem. So let's go ahead and jump to 4. I'm going to be skipping around. So number 4, we're going to have some items that can reduce, which is a good thing. So the first thing we can recognize is we recognize that 85 and 25 can be reduced. So let me go ahead and rewrite this as multiplication of the top times the top and the bottom times the bottom. 25 times 27 n squared. Now, what we can do is we can divide both 85 and 25 by 5. What results? Well, 85 divided by 5 is 17, and 25 divided by 5 is 5. There's another thing we can reduce. I'm going to change color so you see the change. So we have an n in the top, so that can cancel, with one of the n's in the bottom. Okay, so that's literally like this. If we have n over n squared, that's the same thing as n over n times n. So we could cancel one of the n's in the top with one of the n's in the bottom, leaving us just one of the n's in the bottom. So I'm going to cross this out, this 2 out, because that 2 went to a 1, and n to the first is just n, and the n in the top gets removed. So now we just have 79 and 27. Well, I know 27 is divisible by 3 and 9, and that's it, and then 27. So I know 79 is not divisible by 3, because 7 and 9 do not add up to a number that's divisible by 3. So now I just need to see if it's into 27, and it's not. So my final problem results in this. 79 times 17 over 5 times 27 n. So I can go ahead and do that multiplication, and I get 1,343, over 5 times 27, 135 n. And that's my final answer, and that is the most reduced it can be. Moving on, let's do a more complicated one with some different terms here. So let's go on to number 8. So number 8, it looks like a doozy of a problem, but you'll soon find out that it's not that bad. So we could go ahead and multiply top times the top, bottom times the bottom if we wanted to. But before we do that, we should cancel if possible. Do we see anything that can cancel from the top and the bottom? Well, yes. We have something in the top, n plus 4, and something in the bottom, n plus 4. So you can go ahead and cross those out. It's reduced. Now, what about this n minus 3 and this n minus 3? Well, you can go ahead and put parentheses around this top one So if you can cancel the n plus 4 and n plus 4, then you should be able to cancel the n minus 3 and minus 3. Why can you do that? Well, if this is multiplication, anything that you see in the top can be canceled with anything in the bottom, even if it's not in the same fraction. See how we have two different fractions? That's okay, because that's what we ended up doing in these examples anyway. We ended up combining it all under one fraction and then canceling it later. A common mistake I see with these types of problems, just an FYI, is I see people doing, cross multiplication. This is not a cross multiplication problem. The only time you cross multiply is if you have a variable like this with an equal sign separating the two. Let's make this over 5. That's the only time you use cross multiplication, okay? So do not do that when it's just expressions. That means no equal sign. All right. Now, we canceled a lot already, so let's go ahead and see what we have to work with. We have 7n squared times 1, which is just 7 when squared. And then we canceled n minus 3, n plus 4, so now we're just left with n plus 8 and n plus 6. I'm going to leave it like that. It is all in terms of multiplication. There's nothing left to cancel, so that is my final answer. It's as simple as that. Let's go ahead and just do one more just so you get the idea. We'll go ahead and jump to number 14. So number 14, you'll realize that we have a problem. We do not have these two terms. Number one, they're not the same, so we can't cancel them. And number two, it's not in factored form. We want it to be in factored form, which means multiplication, because then we can cancel easily. If it's addition or subtraction separating them, unless it's in parentheses like it is up here, then we can't cancel. So the first thing we need to do is we need to factor. Okay? So I'm going to go ahead and rewrite this problem below. So I have 7n over, and now I need to factor. What are my common factors between 24n and 64n squared? Sorry, 24n cubed and 64n squared. So I know that 2 goes into both. I know that 8 goes into both. I think 8 is the biggest number that goes into both. Yes, it is. So 8 is going to be factored out. Now I also see that we can factor out an n squared out of both terms. What's left? Well, 8 times 3 gives me 24. N squared times n gives me 24n cubed. I'm going to copy down the minus sign. 8n squared times 8 gives me 64n squared. So that's my reduced form there. Moving on. Over here on the right side, I see that out of 9n minus 24, I have a common factor of 3 again. Well, not again, but a 3. What's left? I have 3n minus 24 divided by 3 is 8 over 7n. Now I can start canceling because it's all multiplication. We have multiplication here, we have multiplication here, and this plus and this minus sign is in parentheses, so that's fine. We can work with that. Okay, so now let's go ahead and cancel like terms. 7n, 7n, 3n minus 8, 3n minus 8. What is left? 3 times 1 over 8n squared. Final answer. Hope this was helpful. Good luck out there.